Namaste students. Today we will study some basic terms which are used in the electrochemistry. These are conductors, insulators, electrolytic conductivity, electronic conductivity, factors affecting electrolytic conductivity, molar conductivity, equivalent conductivity, and effect of molar conductivity and equivalent conductivity with dilution. These are the common things which we have to study today. So first of all, we'll talk about conductors. First of all, we'll talk about conductors. Now, what are conductors? Conductors are those substances which allow the electricity to pass through them are known as conductors. So, the substance which allow electricity to pass through them are known as conductors. These are conductors. So the substance which do not allow electricity to pass through them, they are known as insulators. So what are insulators? Insulators are the substance which do not allow electricity to pass through them. So conductors are the substances which allow electricity to pass through them, just like metals. Metals are the conductors because they allow electricity to pass through them. Whereas if we talk about the non-metals or rubber, these are the substances which do not allow electricity to pass through them, so they are insulators. Now if we talk about conductors, we have two different types of conductors. First one, electronic conductors. Now, what are electronic conductors? Electronic conductors are those conductors in which there is a passage of electricity by the flow of electrons. Means these are conductors. Means they'll allow electricity to pass through them, but the electricity will pass by the flow of the electron. So flow of electron is responsible for the passage of electricity in electronic conductors. And second one are electrolytic conductors. Now what are electrolytic conductors? Electrolytic conductors are those conductors in which the electricity flow, in which the passage of electricity is due to the flow of the ions. It means in electronic conductors there is passage of electricity without the decomposition of the substance, because here it is due to the flow of the electron will flow but the substance remains same, but in this the substance get decomposed into ions, and due to the movement of the ions there is a passage of electricity. So we have two types of conductors, electronic conductors and electrolytic conductors. In electronic conductors, due to the flow of electron, electricity will pass. In electrolytic conductors, due to the flow of ions, electricity will pass. Now, the substances which shows electrolytic conductivity are known as electrolytes. So what are electrolytes? Electrolytes are those substances in which, because of the movement of the ions, there is the passage of electricity. So the substance which shows electrolytic conductance are known as electrolytes. We have two types of electrolytes. One are strong electrolytes and another one are weak electrolytes. One are strong electrolytes and another one are weak electrolytes. Now what are strong electrolytes? Strong electrolytes are those electrolytes which undergoes complete decomposition by passing the electricity. Means whenever electricity will pass through the strong electrolyte undergoes complete dissociation, complete decomposition. And when there is a partial decomposition of the electrolyte, then the electrolyte is termed as weak electrolyte. means the number of molecules which are present in the electrolyte. If all the molecules get converted into ions, then the electrolyte is termed as strong electrolyte, and if some of the molecules get converted into ions, then the electrolytes are termed as weak electrolytes. Now here one term is there, that is dissociation constant. Dissociation constant, which is represented by alpha. Now what is dissociation constant? Dissociation constant is a ratio of the total number of the molecules which are present in the electrolyte and the number of the molecules which undergoes dissociation or decomposition by the passes of electricity. So the number of the molecules dissociated divided by the total number of the molecule is known as alpha. And if we talk about for a strong electrolyte alpha is always equals to 1. Why? Because what is alpha? Number of dissociated molecules divided by total number of molecules. Now what are a strong electrolyte? In which all the molecules get dissociated into ions. So these two are equal and alpha becomes 1. But in weak electrolyte there is partial dissociation of electrolyte. Means the dissociated molecules are always less than the total number of the molecule. It means this one is always less than that of the denominator. So alpha is always less than 1. Alpha is always less than 1 for weak electrolytes. So conductors, insulators, electronic conductors, electrolytic conductors and electrolytes, strong, weak and dissociation constant. Now we'll study the factors which affects the electrolytic conductance. The factors which affect electrolytic conductance, not electronic conductance. We are dealing with electrolytic conductors. Electrolytic conductance. Now the first factor which affect the electrolytic conductance is the nature of electrolyte. Suppose we have two electrolytes A and B. A is a strong electrolyte and B is weak electrolyte. So in which electrolyte we get more conductivity? Obviously in A, because A is a strong electrolyte and it undergoes complete decomposition, and when it undergoes complete decomposition it forms greater number of ions. Greater number of ions means large amount of electricity will pass through the electrolyte. So strong electrolyte increases the conductivity, whereas weak electrolyte decreases the conductivity. Second, size of the ions and their solvation property. Size of the ions and their solvation property. Now, greater the size of the ion, greater is the difficulty in moving from one place to another place. Clear? Greater the size of the ion, greater is the difficulty to move from one place to another place, and lesser is the conductivity. So greater the size of the ion, less is the conductivity. Smaller is the size of the ion, greater is the conductivity. What do you mean by solvation? Solvation means tendency of the ions to react with the solvent or to form solution with the solvent. If there is a high tendency of the ion to react with the solvent, so it not remain in the form of ion, and if not remain form in the ion, then there is less conductivity. So greater the size of the ion, lesser is the conductivity. Greater is the solvation property of the ion, also lesser is the conductivity. Now third one is the concentration. Concentration of electrolyte. Concentration of electrolyte. Now if we talk about strong electrolyte or weak electrolyte, Greater the concentration, lesser is the conductivity. Greater the concentration of the ion, lesser is the conductivity. Now the reason behind this, if we talk about in weak electrolyte, in weak electrolyte, if we have higher concentration, then the number of ions are less, and if number of ions are less, then the conductivity is also less. Now if I talk about strong electrolyte, now in a strong electrolyte, whether we have higher concentration or we have less concentration, in both the case we have all the molecules present in the form of ions. But if we have high concentration, then there is interionic repulsion. There is interionic attraction, There is interionic attraction between the oppositely charged ions. As a result of which ion remains stuck at each other. They will not flow from one point to another point, and hence reduces the conductivity. So whether we are talking about weak electrolyte or strong electrolyte, in both the case, if we increase the concentration of the electrolyte, then the conductivity decreases. Next, fourth is the temperature. Now, in temperature, there is a question in temperature that why electrolytic conductivity increases with increase in temperature, whereas electronic conductivity decreases with increase in temperature. Clear? Question is clear to you? That is why electrolytic conductivity increases with increase in temperature, and why electronic conductivity decreases with increase in temperature. Now the reason behind this is, if we talk about the electrolytic conductivity is due to the flow of ions. So when we increase the temperature, the molecules which remain in their undissociated form, they get dissociated and form ions. Means whenever as we increase the temperature, the undissociated molecule also get dissociated, as a result of which number of ions increases, and due to the increase in the number of ions, electrolytic conductivity increases. But if we talk about electronic conductors, in electronic conductors, the conductivity is due to the movement of electron. When we increase the temperature, the atoms which are present around the electrons, they absorb the amount of the heat, as a result of which their vibration increases. Because of the increase in the kinetic energy, their vibration increases, and due to the increase in the vibration, they create an hindrance in the path of the movement of the electron, as a result of which conductivity decreases. And because of this, if we talk about in summer season, the flow of the electricity is less in the wires. Why? Because of the high kinetic energy of the metal ion, because of the greater vibration of the metal ion, which create an hindrance in the path of the movement of the electron. So with increase in the temperature, electrolytic conductivity increases, but electronic conductivity decreases. So these are the factors which affects the electrolytic conductivity. Now we'll study some other terms. In 10th, in physics, we have studied about Ohm's law. And in Ohm's law, we have studied that R equals to V upon I, where R is the resistance. Now what is the resistance? Resistance is actually the property of a material to prevent the flow of the electron. That is the resistance, the property of any element to prevent the flow of the electron, that is resistance. Now here we'll introduce a term, that is conductance. Which is represented by G. Now what is conductance? Conductance is the ability of the material to pass the electricity through it. Means it is opposite of the resistance. Resistance is the ability of the material to stop the current, whereas Conductivity is the ability of the material to pass the current. So the reciprocal of the resistance is known as conductance. The reciprocal of the resistance is known as conductance, and its unit is ohm inverse. Its unit is ohm inverse or mho, mho or sim. Clear? Why it is ohm inverse? Because the unit of R is ohm. So the unit of G becomes ohm inverse because it is the reciprocal of R. So what is conductance? Conductance is the ability of any substance to pass the current through it, pass the electricity through it. It is the reciprocal of the resistance. Lower the resistance, higher is the conductance. Clear? So G equals to 1 upon R. In 10th, we have studied one more relationship, that is R equals to rho L upon A, where rho is the specific resistivity. So here also we'll introduce a term that is specific conductivity. Specific conductivity, it is represented by K, and K is the reciprocal of specific resistivity. K is the reciprocal of specific resistivity. Conductance is the reciprocal of resistance. Specific conductivity is the reciprocal of specific resistivity. And because of this, here it is rho is equals to R A upon L. R equals to rho L upon A. So rho equals to R A upon L. Therefore, K equals to G L upon A. So this is the relationship between the specific conductivity and the conductance. K equals to G L upon A. How we get this equation? By putting 1 upon K here and 1 upon G here. Then on solving this, we get K equals to G L upon A. So conductance is the reciprocal of the resistance, whereas conductivity is the reciprocal of the resistivity, and its unit is, what is the unit of this quantity? The unit of this quantity is ohm meter or ohm centimeter. So the unit of this is ohm inverse, meter inverse, or ohm inverse, centimeter inverse, or Siemens meter inverse, or Siemens centimeter inverse. Clear? On the basis of the unit of resistivity, we can find the unit of the specific conductivity. Now we'll introduce our third term, that is equivalent conductivity. We'll introduce our third term, that is equivalent conductivity. Now equivalent conductivity is represented by lambda EQ. Now, first of all, we will talk about the definition of equivalent conductivity. Now, equivalent conductivity may be defined as the conductivity of all the ions produced from 1 gram equivalent of the electrolyte dissolved in V centimeter cube of the solution when the distance between the electrode is 1 centimeter and the area of the electrode is so large that whole of the solution will contain between them. Clear? Conductivity. What is electrolyte equivalent conductivity? Equivalent conductivity may be defined as the conductivity of all the ions. Conductivity of all the ions. Now from where we get the ions? Of all the ions produced from 1 gram equivalent of the electrolyte. We will take 1 gram equivalent of the electrolyte in V centimeter cube of the solution. Here we will take V centimeter cube of the solution. In this V centimeter cube of the solution, we have 1 gram equivalent of the electrolyte, and the ions which we get from 1 gram equivalent of the electrolyte, the conductivity produced by those ions are known as equivalent conductivity. But there is a condition, that what is that condition? The conditions are electrodes are 1 centimeter apart from each other, and the area of electrode is so large that whole of the solution is contained within it, contained between them. Clear? So in this case, when we get the conductivity, after this, when we get the conductivity, that conductivity is known as equivalent conductivity. So equivalent conductivity is defined as the conductivity of all the ions produced from 1 gram equivalent of the electrolyte dissolved in V centimeter cube of the solution when the distance between the electrode is 1 centimeter and the area of the electrode is so large that the whole of the solution is present between them. Now, mathematically, lambda EQ is equals to K into 1000 divided by normality. K into 1000 divided by normality. This is the mathematical formula for calculating equivalent conductivity, and through this formula we can calculate the unit of this. What is K? K is the specific conductivity. Now the unit of specific conductivity is ohm inverse, meter inverse. 1000 is centimeter cube, so it becomes meter cube divided by normality is gram equivalent. So the unit becomes ohm inverse, meter square, gram equivalent inverse. This is the unit of equivalent conductivity. This we get from the formula. So equivalent conductivity is defined as the conductivity of all the ions produced from 1 gram equivalent of the electrolyte when dissolved in V centimeter cube of the solution when the electrodes are 1 centimeter apart from each other and the area of the electrode is so large that whole of the solution is contained between them. This is known as equivalent conductivity. Now, similarly, we will study molar conductivity. Now, how we will study the molar conductivity from this content only? First of all, we will write molar here, and when we will write molar here, it becomes lambda m. Now, what is lambda m? Lambda m may be defined as the conductivity of all the ions produced by 1 mole of the electrolyte. Because it is molar, so here we are dealing with molarity, and there it is equivalent. That's why we are dealing with equivalent conductivity. That's why we are dealing with gram equivalent. Here it is molar, mole, there equivalent. That's why gram equivalent. So conductivity of all the ions produced from 1 mole of the electrolyte dissolved in V centimeter cube of the solution when the electrodes are 1 centimeter apart from each other and the area of electrode is so large that whole of the solution is contained between them. This is the definition of molar conductivity. Simply, we have to replace only by first of all symbol and second mole in place of gram equivalent. And here also I'll replace one thing, that is lambda m, and here in place of molarity I'll write, in place of normality I'll write molarity. So my unit becomes also, in place of gram equivalent it becomes mole, and here it also becomes mole inverse. So molar conductivity unit becomes ohm inverse, meter square, mole inverse. So in this way we can define equivalent conductivity and molar conductivity. Now we will study the variation of conductance, specific conductivity, equivalent conductivity and molar conductivity with dilution. Variation of conductance represented by G, specific conductivity represented by K, molar conductivity and equivalent conductivity with dilution. Now, conductance, molar conductivity and equivalent conductivity increases with increase in dilution. Means if we dilute a particular solution, if we have a solution and we are diluting that solution, in that case the conductance, molar conductivity and equivalent conductivity of the solution increases. But specific conductivity of the solution decreases. Specific conductivity of the solution decreases. Now, why it is decreases? First of all, if I talk about G, that is G. G is conductance. Okay, conductance means ability to pass the electricity through it. Conductance is the ability of a substance to pass the electricity through themselves. Clear? More the number of the ions, higher is the conductivity. Means more the number of the ions, greater the number of the ions, greater is G. Now with dilution, number of ions increases. With dilution, number of ions increases. And if number of ions increases, G increases. If number of ions increases, G increases. If I talk about K, now what is K? K is specific conductivity. What is specific conductivity? Means conductivity of 1 centimeter cube. Conductivity at 1 centimeter cube is known as specific conductivity. Suppose I have a beaker. Now up to this point the solution is filled in it. So overall conductivity is known as G. The overall conductivity of the solution is known as G. But if I am dealing about the conductivity of a specific portion, conductivity of 1 centimeter cube portion, then it is known as K. Now suppose here I have 2 beakers. Initially I have this much amount of solution. Now when I add water, the solution level becomes this on adding water. Clear? Initially the solution level is this, but when I add water, means on dilution, the solution becomes this much. Clear? Means on adding dilution, volume increases, but initially the ions which are present very close to each other, they'll move far away from each other, because on dilution the water molecule occupy the space which is present between the ions, as a result of which ions move apart from each other, as a result of which the number of the ions present in 1 centimeter cube decreases. Clear or not? On dilution, the number of overall ion increases. But the number of ions at 1 centimeter cube decreases, because at 1 centimeter cube, water occupy the position of the ions. Means water present between the ions. So at 1 centimeter cube, the number of ions decreases. And due to the decrease in the number of the ions at 1 centimeter cube, K decreases. So why specific conductivity decreases? Due to the decrease in number of ions in 1 centimeter cube volume. 1 centimeter cube volume. But overall the ion increases. In overall system the number of ions increases, therefore conductance increases. But at particular point, at particular volume, the number of ions decreases, therefore K decreases. Now if I talk about lambda m equals to K into 1000 divided by molarity. Now what is molarity? Molarity is the number of moles present per liter of the solution. Now on dilution K decreases but volume increases. On dilution K decreases but volume increases, and the increase in volume compensates the decrease of K, as a result of which lambda m also increases. So though K decreases, but due to the increase in the V, lambda m increases. Similarly, in lambda equivalent, it is K into 1000 divided by normality. Now, what is normality? Normality is gram equivalent, number of gram equivalent present per liter of the solution. In this also, though K decreases, but increase in volume compensate the effect, and hence lambda equivalent also increases. So, with dilution, conductance, molar conductivity and equivalent conductivity increases, but due to the decrease in the number of ions per unit volume, specific conductivity decreases. So these are some general points which we have studied in electrochemistry. That's all for today. We'll learn some new things, some new topics in our next video. Till then, take care, stay healthy.